Hello. Test. Okay, so text me here or at my cell phone 406-853-1477 to check in. I don't have a video screen per se, but what I can do is I can screen share and share a lot with you that way. So if you need help. But I do want to know who's here, who's caught the broadcast, who is able to get in. So please let me know, either by phone, text, or by the chat messenger here in Google Hangouts. Still here. And check in with me if you've, not even if you've got questions, just check in me and let me know that you actually made it here. Either by the chat on the right or by texting me if you can't find that. Texting me on my phone 406-853-1477. I'll be waiting here until at least 11:30. We'll get it. Okay. Good morning, Jan. This is Mike. Hi. Just want to catch up on something. Did Caitlin Porter ever find out how to get into the exam, or is she just waiting for me? Yeah. Okay. Wow, that is interesting. So the assignment just not. Wow. Because, yeah, when I went in last night and tried to look for it, it shows up on my syllabus. I look in at the settings. It's supposedly available until, well, last night. So tonight, there may be problems. I'm going to change the setting to make it available till tonight. But yeah, all right. Well, yeah, that's interesting, bizarre. Anyway, my flights got messed around, so I'm sitting on Yahoo or Google Hangouts. Nobody actually joined me, but I put up an invitation to my what's it cost that supplemental support to join me on Google Hangouts, and nobody took advantage of it or saw it or whatever. So we'll have to find out why that was tomorrow. Because my machine here doesn't have the Flash player, so there I go. So I'm going to get that installed when I get back there. Anyway, great. I will see you this afternoon, and I'm on my cell now for the rest of the day. Thanks. Take care. Goodbye. Oh, very nice. Four nine one 4284. Bree, this is Dr. Hardy calling. I'm just curious how this is working. Nobody's apparently found out how to get in. But are you at your computer by chance? Could you possibly get into your class? Now, it's not the class homepage, it's of course, the supplemental support homepage. Okay. Okay, so you're in statistics. Okay, wait a minute. All right. Were we supposed to meet? What was I'm getting confused here. Right now, I'm thinking I'm supposed to be meeting a group of intermediate algebra students. You're I see. I see. Yeah. So what you would do is, yeah, I don't know where you'd go from there, but if you went to the right event, let me just see something here. If there's any way to add apps. Yeah. Oh well. That's yeah. Sorry about that. Yeah. That. Anyway. So Bree, let's just check in on your statistics. We might as well here. So let's go to the course. Um, where's the right page? Here it is. Uh, okay, let's just see. In for the statistics, and I'm going to go to the grade book. Why not? And Syrian is Brianna Williams, correct? Okay. And so homework's in up to 2.4. I have not checked 2.5 on, so I see there's three in beyond 2.5, but there we go. Okay. And then we've got the exam. The exam is 88. So that was after I added in those questions that the different questions, and I also added in 4 point fudge factor because one of the questions I thought was people are clearly not getting it, and I'm not positive why. It's just, but it's sometimes when you teach it online, they just yeah, people clearly don't get what you're selling them, so you have to move on. So there that is. The exam looks fine. Do you have any questions about it? Right now there isn't any. I'm going to go in again, try to put in some more. It was something where I had grand ideas of getting videos into every session, so I typed that in. But then if it doesn't have a blue link on it, it's because I haven't found a video for that section yet. Yeah, yeah. Yeah, and sometimes they won't be able. A lot of times I'll pull them, from not just me, but from someplace here. And so let's see what's the. I'll go back to course home and see what these topics are. All right, it just says section numbers down here, but let's. righty. Okay, there's a nice video for that. I should hook it up if I can find it. Yeah, let me go to YouTube and see if I can find that. Because that should have a video. But yeah, bottom line is we just moved into this, and so a lot of it's relying on the book, and then the idea was to add videos as we went along, and so some of them will have them, and some of them won't. So let's go to YouTube and see if I can find this, or better yet, I'll just go this way. Yeah, and that's fine. That is absolutely fine. Often I'll get Khan Academy videos to consult with that. So let's go to YouTube. Mm-hmm. 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 Oh my. I am betting, without having gotten to actually play it, that this video that I just installed in 2.6 will be helpful. Um, but yeah, as soon as I get home this afternoon or tomorrow, I'll make another run through and try to see how these work and see if I can get a few more videos in. All right. Oh man, I hope I have enough to drive home. I got bumped on my flight, and now I ended up taking a red eye flight, and so there I go. I slept on the planes. All righty. Well, I will see you when I see you. Great. Take care. Thanks for calling. Bye. Okay. Google Hangouts. And now there are 0 viewers. So there was one viewer who didn't chat or enter. Okay. Sorry, guys.
In this unit, we will explore the relationship among the 3 averages we discussed last time. Remembering that the mode is the most frequent value in the sample or population, the median is the value that divides the sample or population into 2 equally large groups, and the mean is the sum of all the values spread out among each observation equally. We get the mean by dividing the sum of the sample size or population, depending upon our data set. By looking at the relationship among these 3 averages, we can learn more about our data. The key to this relationship is the skewness of the data. By skewness, we mean how the data looks in terms of where the most observations congregate. Are the data concentrated at one end or the other? If so, then we would call it skewed. The graphs of frequency distributions of the data are very helpful in visualizing the effect of skewness on this relationship, because we can visually locate the relevant measures of location, the mode, the median, and the mean. This can be done with bar charts, histograms, or line graphs, polygons. Pie charts can be used also by graphing the percentages of each class, but these are not really frequency distributions and can sometimes hide more than they reveal. I've never had much fondness for pie charts, actually. True frequency distributions provide much useful information. The frequency distributions here show just how quickly one can see the data and can begin to make some crude inferences with this simple technique. In figure A, the distribution is skewed to the right, called leptokurtic. Compare this to figure B, which is skewed left and called platykurtic. Think platypus. We could infer that the values of X are bunched at the smaller values in figure A and bunched at the larger values in figure B. Often, income distributions of countries are compared using these measures of skewness. Developing countries, most often, have dramatically skewed distributions looking like figure A. Figure B might be a distribution of grades in the statistics class of particularly good students, or the distribution of golf scores, where the frequency of good scores, that is low scores, is skewed left, and the bulk of the distribution contains the scores of the ordinary players with high scores. Notice that for a skewed right distribution, the mean, X bar, is higher than the median, which is higher than the mode. For a skewed left distribution, like figure B, the order is reversed. Both figure C and D are examples of symmetrical distributions. They have very different spreadness in the data, which we will call variance and take up in the next unit. For a symmetrical distribution, the mean, median, and mode are the same value. 1/2 of the values are on each side of the mean. Remembering the relationship between the area of a frequency distribution and probability, we can conclude that the probability is 1/2, or 0.5, that a random draw will result in a value greater than the mean, or less than the mean. We can go even further with a frequency distribution if it is symmetric. Imagine we move 1 unit from the mean in both directions. If we now shade in the frequency distribution at the tails, we can say that the probability of randomly drawing a value in the upper tail is exactly the same as drawing an observation in the lower tail. This fact will be of great help in the future, and again shows the value of frequency distributions.